So what were we multiplying on last Wednesday when we were learning our vertical and rectangle method? What were we multiplying then? A binomial times another binomial? No, I think it was a binomial.
A trinomial by a binomial.
A trinomial was being multiplied by a binomial, right? And so how many multiplications were involved when there was a trinomial and a binomial in our multiplication problem?
6.
There were 6 of them, okay? So whether you used vertical or you used the rectangle method, you should have had 6 multiplications, and then you decided you could combine any like terms that can be combined so that you get your polynomial answer, because there's no guarantee how many terms will be in your answer necessarily. It all depends on what the results of the multiplication and being able or not able to combine like terms. Okay. Well, if our learning goal today is I can multiply a trinomial by another trinomial, how many multiplications do you think will be involved today?
9.
Why 9?
Because you got 3 and 3. So then you have 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9.
So each term of the first trinomial has to be multiplied by each of the terms of the other trinomial. So the first term of the trinomial has to be multiplied times the other 3. The second term has to be multiplied times those other 3. The third term has to be multiplied times those other 3. So we're really doing distributive property, but it can get pretty messy if we just do it with all those arms. We'd have 9 of those arms trying to show distributive property. So that's why we learned the vertical and the rectangle way last Wednesday, so that we can use it now also for a trinomial times a trinomial. Okay, so we're going to actually only do one of these, but we are going to practice both ways. Okay, even though you might have already developed, you think you have your own favorite way, vertical versus rectangle, rectangle versus vertical. We're going to practice both of them just to give you, another shot at making sure that you, so first of all, we're going to say use rectangle method, or you can choose to use the vertical method. What can't you use? FOIL. FOIL only has how many letters? 4, which would mean there are only 4 multiplications. We need 9. So either you come up with your own 9-letter word that will help you remember how to do the multiplications, or you use the rectangle method or the vertical method, okay? And again, in our notes today, though, we will actually practice both of them. You get to make a choice, though, in your homework, okay? So practice. We're only going to practice one. We're going to multiply x squared, subtract 3x, plus 2, and that's going to get multiplied. The other trinomial in the multiplication problem is 3x squared plus x minus 5. Go ahead and make sure you get the multiplication problem written down correctly first. Always double check to make sure you copied it down right to get yourself a good start. Okay, what's going to be our first move before we do anything else? Add the opposite. We're going to change it to add the opposite. So we're going to have an x squared plus negative 3x plus 2 and 3x squared plus, we can put a 1 in there if we want, if that helps us out, or we can just leave it plus x plus a negative 5. Okay, let's use how about the rectangle method first, okay? Let's do rectangle. What's our rectangle going to have? It's a what by what?
3 by 3.
A 3 by 3. Okay, now, let's just give ourselves a little bit more room today by having a work one, our multiplying one, and then let's have our result one right next door to it, okay? So let's have a multiplying one, then a result one, the products, okay? So, first of all, we need to set up our terms up. Does it matter which one goes on which side?
No.
Okay, so x squared, negative 3x, positive 2, 3x squared, 1x, negative 5. So let's just show our multiplying here, and that's all. We're going to take the 3x squared and multiply it times the x squared. If you want to go straight to the result, you can. Let's do that. Let's just go over to our next one. And what would be the product over here in our product
3x
rectangle?
to the 4th power.
Everybody agree with Cody? He says it's 3x to the 4th. Why is it x to the 4th?
Because
No, Cody,
because-
no. We're going to raise our hand. Noah?
Because when you have a power to something, you add them up.
Yeah, when you're multiplying powers with the same base, you add their exponents, right? Okay, so then our next multiplication is going to be a 3x squared times a negative 3x. What can really be multiplied in this? We can take a 3 times a what? Negative 3. So 3 times negative 3 is negative 9. And then we can take the x squared times the x. And what do we get for a result for that one?
X to the
Next to the third. Do we agree?
Yeah.
Okay. Okay, go ahead and finish the multiplying now, because I think you got this. I know you know how to do it. If you get lost and you're like, this isn't working for me, then you can just look up at my work, I guess, and what should happen when you're multiplying a trinomial times another trinomial and they both are the same degree? What's the degree of both of these trinomials? Cody?
Quadratic.
They're quadratic. They're both a second degree trinomial. So they're both the same degree, and in their degree 2, if they're degree 2, they're going to have all of the terms, and here's what should happen. When you do your multiplication as a rectangle, you should be able to go something like this. You should have nice diagonal groups of like terms like that. And the corners, the top left corner, the opposite right corner, bottom right corner, they should have nothing that can be combined with them. Okay? So basically then we should be able to do this. Say we got 3x to the 4th plus, and we can do the adding right here because I circled it. What's 1 plus negative 9?
Negative 8x.
Negative 8, and those are x cubes, yep. They're x to the 3rd power. We're combining them, we're adding them. Now, if you need to write down all 9 of those terms in one long addition problem, feel free to do it. Do what's going to work for you, and then circle them instead or something in that. If you can do this and then let that be your grouping, then you can kind of skip that. How many x squares do we have? We got a -5 plus -3. What's that?
That's
-8.
-8. And then we got a -8 plus 6. What's that?
-2x.
-2x to the second power. Okay? And now we got our third group of like terms. We got a 15 plus a 2. What's that?
17.
17x. And then we have that -10 here that doesn't have anything it can be combined with. So plus -10. And now all we should have to do is clean this up. We've already done all of the combining of like terms. Again, if you need to write all 9 of those terms down like this, 3x to the 4th plus -9x cubed plus 6x squared. Notice what happens though when I start doing it like this. Are the like terms by each other in that? No, they kind of get out of order, don't they? So that's the advantage too. If they line up nicely in the diagonals, then you don't have to have all of this, and then they're not in nice order, and I'm going to run out of room here, okay? So now I got all 9 of them, and now I got to rearrange so that I can see what terms are like each other, and so. Okay, what's the final answer for this one? 3x to the 4th?
-8x to the third. -2x.
Plus 17x minus 10.
Leave it up. Okay, now, not always though, just be cautioned, not always do they line up nicely in diagonals like this. You gotta know when they will and kind of like when they won't. They should, when the polynomials that you're multiplying times each other all have the same types of terms. So these both had some x squareds, these both had some x's, these both had some constants. That's why they lined up so nicely. Okay? Anybody have any questions multiplying a rectangle? Okay, let's do it vertical now, wherever you've got the room to do that. So let's use the vertical method now. We've already renamed it. We shouldn't have to rename it again. Doesn't matter which one's on top?
No.
Because they're both the same length, aren't they? They both have 3 terms. So 3x squared plus x plus -5. And our other one is x squared plus -3x plus 2. Okay, this is the one that might be a little trickier for some of you because you have to make sure that you're doing all of the multiplications. How many rows should there be now down here? Should there only be 2 like we had for today, Cody?
There should be 3.
There should be 3 because that 2 has to get multiplied times every piece in the upper one. That's the first row. Then our -3x is going to get multiplied by everything in the upper row. That's our second row. And then that x squared is going to get multiplied by everything in that row up above, and it'll be our third row. So we're going to take 2 times -5. What is that? -10. Bring down our plus sign. 2 times x, 2x. Bring down our plus sign. 2 times 3x squared, 6x squared. Okay. When we start our second row, do we want to start all the way over to the right?
No.
Put our
Put a 0.
multiplication. We want to put a 0 there or leave it empty, okay? So it's one or the other. I'm going to use a different color here. Okay, so you can put plus 0 there or you can just leave it empty and put your first multiplication in the second column. So -3x times -5, Faith? 15x. Bring down our plus sign. -3x is now going to get multiplied times that x. What's that?
-3x squared.
What is it?
Yeah, -3x squared.
Okay, I just wasn't sure I heard what you said. -3x squared. Bring down a plus sign. And now we have to take the -3x times the 3x squared. Negative 3 times 3,
Negative 9x.
negative 9, x squared times x squared, or excuse me, x times x squared, x cubed, yeah. Got a little, I was in the third row already. Okay. And we're ready to move on to our last row of multiplication. Are we going to start over here at the right? Okay, let me use a different color here now. Okay, so I can use black. Are we going to start here? Nope, we're going to have to put another plus 0, aren't we? Those are really 0 x's, aren't they? Or just 0 is fine. Now we're ready to start multiplying. Now we're ready to say x squared times negative 5 is?
Negative 5x squared.
Yeah, we want things to line up. Notice we want things in columns that are like terms. Okay, I didn't allow myself enough room here. X squared times x cubed. And then over here to the left, hanging out by itself will be what?
3x to the 4th power.
3x to the 4th power. I'm going to have to kind of drop mine down here because I don't have enough paper over there side. And I can't add more on that side. Okay? So, the 3x to the 4th is over here. It's not, it's in a column by itself, isn't it? Okay, now we're ready to add those 3 rows together. Okay, so now, what happens in this one?
You just add them.
Negative 10. What happens in this one?
17.
17x. Bring down our plus sign. Don't forget those plus signs, okay? What happens in this one?
Add
Okay.
Okay,
Two.
this is a negative 8, plus
Negative
6 is
2x to the
negative
second
2x to the 2nd power. Bring down a plus sign. What happens in that column?
power.
Okay, this is this a plus right here? Right? So this
Yes.
is a negative 9 plus 1, which is negative 8x to the 3rd. And our 3x to the 4th comes down next. Okay. Now we're ready to clean up our answer. So we got 3x to the 4th kind of scrunched in here, plus negative 8x cubed, plus negative 2x squared, plus 17x, plus negative 10. And now we're just going to clean it up. And hopefully we end up with the same result that we did when we used the rectangle. Leave it so I can compare them. Yep, ended up with the same thing. Okay. So just by looking at the papers when I went around to stamp, it appeared that the more popular method is the rectangle method. But there are some of you who do like vertical. So you get to use whichever one works for you. Okay? Anybody have any questions? Okay, in today's homework, you're not just going to be doing trinomials times trinomials. It's a lesson 6.5 practice worksheet. This was our 4th set of notes. Let's go find all those other notes right now. Go find all your other notes for lesson 6.5, please.